Hello, this is the solar panel coating evaluation team for Grand Valley State University. The team consisted of Austin Cordes, Megan Gerard, Dan Jones, Paul Rakowitz, Josh Robinson, Kelly Schultz, and Jacob Weises. Our sponsor contact was Dr. Zhao, and our faculty advisor was Dr. Peng. Our problem statement was that this project encompassed multiple tasks with the final objective of being able to evaluate the performance of 3 selected solar panel coatings. The coatings were evaluated for their resistance to abrasion and their resistance to dirt and debris buildup. In-lab and field testing plans were conducted with this goal in mind. The project overview and key specifications, it was broken down into 2 different categories, the in-lab testing and the field testing. For the in-lab testing, we had the CNC airbrush cleaning test, which was used to determine the cleaning method that would cause the least amount of damage to the testing surface. Then there was the forced and falling sand tests, which were tests that were performed to test the coating resistance to abrasion under varying conditions. Then there was the light simulator, which was used to simulate lighting conditions to evaluate performance after various tests were performed. And then there was the field testing, which was the evaluation of field performance of the selected solar panel coatings. The in-lab testing fixtures, as you can see on the left side, there is the light simulator that we designed and built, and then there is the CNC controlled cleaning fixture with a brush or compressed air, which was an interchangeable head. Then there was the forced sand test fixture and the falling sand test fixture. For the standard in-lab testing procedure, the first step was to apply the coating to the testing surface. The second step was to take an initial light simulation test reading, and then a falling or forced sand test was performed. A light simulation was then taken after the falling or forced sand test. Then a CNC controlled cleaning was performed on the surface, and then a third light simulation test was performed. All of the data was recorded and put into a table, just like the sample data collection table that you see on the right side. For the field testing consisted of placing a group of panels in a location for a given period of time and evaluating the performance. These test groups consisted of 4 different panels, 3 of them which were coated, 1 of each of the selected coatings, and then 1 control panel. And then we placed them in 3 different locations. The first site was the roof of the Keller Engineering Building, the second was Holland State Park, and then the third site was the Allendale Campus Sustainable Agricultural Project. And the data collection occurred weekly. There were 3 major challenges that we had to overcome during this project. The first being designing testing procedures and fixtures to meet testing standards. The forced sand testing fixture in particular required further refinement after initial testing to meet the requirements and to ensure consistency. Then the second challenge was the testing to specifications. We had a limited material availability for the forced and falling sand testing, which made this hard. And then the third was the timing in order to perform all of the testing required. For the results and overall performance, we successfully designed and built fixtures to allow for testing of solar panel coating performance, and then we built and deployed solar panel installations in 3 locations: Keller Engineering Building, Sustainable Agricultural Project in Allendale Campus, and Holland State Park. Thank you.